To another lecture video. This is the second portion of our chapter 10 unit, and it's ionic compounds. And so with today, we're going to make sure that you guys understand how to write and name ionic compounds. So first things first, take a look at this picture. Okay, we have lithium. Lithium is the third element on the periodic table, and fluorine is number 9. Okay, take a minute, take a peek. What is happening in this picture? What we're seeing is we're seeing lithium with its outer shell electron, the one that it has, and an arrow pointing to the last spot where fluorine's missing an electron. So, in an ionic compound, when they're formed between a metal and a nonmetal. So if you were to look at your periodic table, lithium is a metal, fluorine is a nonmetal. So, ionic compounds exist between metals and nonmetals. In other words, one atom is going to actually steal one electron from another atom. So if you look here, this electron is going to get donated to fluorine, or you could also say that fluorine steals this electron from lithium. Okay? Electrons are going to transfer from one another. So again, we're moving this electron to fluorine. And just as a piece of review, if you don't remember, if we say ion, this is any atom with a charge. And to take it a step further, this is going to show up again, but to take it a step further, if we donate an electron, lithium is going to become more positively charged. So this is what's called a cation. Fluorine over here is going to receive an electron, so those are called anions because they become more negative. Okay, so in this example, lithium is going to donate its electron to fluorine. So we're going to keep this up when we're talking about forming ionic compounds. So the positive charge of a cation is attracted to the negative charge of an anion, creating an ionic bond. So what happens is after this electron is donated, these two atoms are actually going to merge pretty closely together because of that opposite charge attraction. So, like I just mentioned, in other words, opposites are going to attract. This is super, super, super important. If you need to highlight this in your notes, if you need to star it.
Good morning. The middle school and high school MTSS teams will be meeting in the Innovation Center at 7:35 today. Middle school and high school MTSS teams, please meet in the Innovation Center at 7:35. Thank you.
I apologize for that, students. There's an announcement over the intercom, and so it's hard to talk over it. But this is super, super important. So please make sure that you highlight this, that you star it, that you circle it, whatever. When we're talking about ionic compounds, the oxidation numbers or charges must add up to equal 0. That is super, super, super important. Okay? We already mentioned this, but a cation is an atom with a positive charge, so in this case it's lithium, and an anion in this case would be fluorine because of the negative charge. But when we're talking about the charges, if we were to look at lithium, okay, lithium, when it donates an electron, if it has one less electron, we know that it's a positive charge. When fluorine receives an electron, we know that it's going to become slightly more negative. So 1 plus a negative 1 equals 0. That means that this compound right here can actually exist and can form, because for every 1 fluorine we need 1 lithium. Okay, so those charges can offset. So when we're talking about naming ionic compounds, there's 2 different types, and today we're just going to talk about binary. Okay, these are composed of only 2 different types of elements. So if you think bi, right, the prefix bi, it means 2. So that's why we have an underlined 2 here. Those are 2 elements. Okay, so if you look at these examples, right, we have magnesium and bromine. Those are 2 elements. Calcium and chlorine, 2 elements. Sodium and oxygen, those are also 2 elements. Okay, so when we're talking about naming binary compounds, we have 3 simple rules that we're going to follow. The first is we're just going to write the name of the first metal. So in this case, if I was using magnesium and bromine, I would start off with a capital magnesium. So capital M, magnesium. Okay? The second is you write the root of the name of the second element, or the nonmetal. So with this one, with it being bromine, what we're going to do is we're just going to write bro or brom. Okay, and it's going to be written in lowercase. So we're not going to capitalize the B on bromine. Okay, and then the last step is we're going to add the suffix IDE to the root. So instead of bromine, this actually becomes bromide. Okay, so here are some examples for anions that actually switch their suffix. So for chlorine, we switch it to chloride. For oxygen, becomes oxide. Nitrogen becomes nitride. Sulfur becomes sulfide. Phosphorus becomes phosphide. And then hydrogen becomes hydride. So notice how all of these suffixes have that green IDE. It's color-coded for you, okay? Because the element, which is on the left, becomes the root plus the IDE ending, okay? So let's get some practice. Here's what I want you to do. I want you to look at the following formula. So in this case, we have NaCl. And what I want you to do is just take a second to write these down. There should be 4 or 5 of them in your note outline. So go ahead and pause the video and try to get these answered. All right, everybody. So first rule, it says write the name of the first element. So the first element here, Na, that's sodium. Okay, so we're going to capitalize sodium. Then we're going to write the root of the second element. So in this case, it's chlorine. So I'm going to write chlor in lowercase. And then lastly, I'm going to add IDE. So we get sodium chloride is the correct answer for this compound. Okay. Then for this one, we had MgO. With MgO, our first element here is magnesium. We're going to write the root of the second element. In this case, it's oxygen, so I'll just write oxy. And then lastly, I add IDE. This is magnesium oxide. Then we have K2S. K is potassium. S is sulfur. But we know it's not sulfur, it's sulfide. So this is potassium sulfide. And lastly, we have strontium. This is kind of a fun one to pronounce. Strontium. And then we have bromine. So if I combine those and I change the root of my nonmetal, in this case bromine, it becomes strontium bromide. All right. So that is naming ionic binary compounds. We're going to pick up the next lecture video talking about ternary.